So we need to look at some applications of these right triangle thingies that we were looking at. One of them, well, we've kind of talked about this one before, but we're going to talk about it again. Come on. Actually, I don't want to draw it like that. Let's draw it like this. Let's say there used to be a bridge across a river, and the posts are still there. You know that the posts are square. In other words, that if I connected them, come on, if I connected them like this is going to form a rectangle. All those corners are going to be right angles. You know that much. You do not know how far it is across the river. That's what you want to find, that distance. So you measure here and you find that the distance between these posts here is 24 feet. And did we talk about a theodolus much? We mentioned it, right? Yep. Yep. So you use your trusty theodolus to set up here, and you shoot it this way to get a 0 degree angle that way, right? Then you turn it this way, shoot it here, and you come up with this angle as 73 degrees. Now, of course, this x over here is going to be the exact same as this distance, because rectangles, opposite sides of a rectangle, should be the same length. How are we going to find x? Well, we're committing to using this angle. So we've got the angle that we're going to use. Now we identify the side that we know. What side do we know the length of? 24, and which side is that? That's the adjacent side. The hypotenuse opposite adjacent, that is the adjacent. So then we look at the side that we're trying to find. X, which is which side? Is the opposite. On your little formula card, what trig function is opposite and adjacent? Tangent. What is our definition of tangent? What is the definition of tangent? Tangent of theta equals opposite over adjacent. It always helps me to write out that formula. It keeps me from making some really silly screw-ups. Now, obviously the tangent is still going to be used. Do I know this angle theta? 73 degrees. Do I know the opposite side? No, that's x. That's what I'm trying to find. Do I know the adjacent side? 24. Now I have to ask myself, am I looking for an angle or am I looking for a side? I'm looking for a side. Remember, if we were looking for an angle, that's when we use the inverse trig function. But I'm looking for a side, and when we're looking for a side, we make this into a proportion, and we do that by putting the trig function over 1. And once it's a proportion, we cross multiply and divide. So it's tangent to 73 degrees times 24 divided by 1. So tangent of 73, make sure you close those parentheses, times 24 divided by 1. 78.50. So x here is 78.50 feet. Make sense? 78.5. We went over the angles of elevation, angles of depression, right? Tate looking for his boat to come in, and
oh yeah, oh, sure.
Yeah.
Big boat, that's what pirate big boat, right? You're pirate ship. Pirate ship.
Should be Tate's ship. Yeah. We're going to do a CNC setup for you here. And what we're looking at here is you have a round piece. Pretend that's round. And what you want to do is you want to mill it off flat, right? And you're going to want to mill it off flat 1/2 inch from the top. This has a diameter of 6 inches. You understand what I'm talking about by mill, right?
Yeah.
It's just a round, it looks like a drill that has teeth on the sides of it, and it cuts. You use it to cut grooves in like the sides of your cutting boards and stuff like that. Yeah, it goes in and then it moves sideways instead of just up and down. So you go back and forth across that to get that flat surface on it. So with that diameter of 6 inches, you got this here is 2 inches. This thickness here is 5 inches. I want to know where to set my mill. In other words, what distance from here up to here to set my mill so I get that 1/2 inch milled off of there. We take round pieces. This is what we call a V block. When you're taking a round piece and you want to stabilize it, you set it in a V block like this. It wedges it in there and it stays nice and tight for you so you can do what you need to with it. So let's figure out that height. Well, when we are looking to use trig in problems like this, we must find right triangles. To find right triangles, we must find right angles. Now, in many of the problems we've done so far, they've been given to us. Like here, I gave you that formed a rectangle, so we know those 4 corners are right angles. Other examples we've done, we did Tate chopping down the tree, right? Well, in that one, you've got the ground that's horizontal, you got the tree that's vertical. Horizontal to vertical form a right angle. So you've got one way to find right angles is they're given as right angles. 2 is horizontal and vertical always form right angles with each other. The third one, the one that we're going to experience in this problem, is a tangent on a circle and a radius. When a circle is sitting up against a flat surface, that flat surface is tangent to the circle. So this is down in a V block. There are 2 spots where this is tangent, this side and this side. That radius is going to form a right angle on that side, and it's going to form a right angle on this side. We know the radius is 3 inches. We do have to be given the angle of the V block. So if I tell you that that angle there is 100 degrees. Now, remember, when we were talking about circles, we said a couple of things. One is 2 tangents that intersect outside the circle. Obviously, they have to intersect outside the circle because they never go in the circle, right? Cut each other into equal lengths. So those 2 lengths are both the same. Second thing we discussed was if we go from the center of the circle out to the intersection of the tangencies, what can we say about those 2 triangles created? They're equal. Which means that this angle here is how much? 50, just half of the 100. So what I'm looking at here is this triangle. This is 50 degrees. This is 3 inches. I want to find this side here. So I'm committing to that 50-degree angle because that's the one I have. I know the 3-inch side. What side of the triangle is that? That is the opposite. I am trying to find, I'm going to call this side here P. I'm trying to find side P. Which side of the triangle is that? Hypotenuse. What trig function deals with hypotenuse and opposite? Sine. So I'm going to write out the definition of sine. Sine theta equals opposite over hypotenuse. And I'm going to plug in what I know. Do I know the angle? 50 degrees equals, do I know the opposite side? Yes, that's 3 inches. Do I know the hypotenuse? No, that's P, what I'm looking for here. So am I looking for an angle or am I looking for a side? Looking for a side. So when we do that, we set it up as a proportion. So we put the trig function over 1. And we will cross multiply and divide. So I'm going to do 1 times 3 is 3, divided by the sine of 50. So 1 times 3 divided by the sine of 50 degrees. Making sure I close my parentheses for good form. And I get 3.916 inches. Okay. So what this is telling us is that from here to the center of that circle is 3.916 inches. How far is it from here up to the top of the circle? No, from here to here would be 3, just the radius, right? So from here to there is how far? 2.5, right? Taking off just a half inch, right? Just a half inch. So it's 3 minus a half inch.
Oh, that wasn't a 1?
No, that's just a half.
Not bad.
It's okay. So now we add those up. We've got 5, 6.4. Adding up these 3 measurements, of course, give us 8.416 inches. Yes, no? .416. There we go. So that is how far above the base of our table, whatever that we're setting that V-block on, that we would set that mill to cut that half inch off of there. What do you think? Good stuff? There's a step or two in it.
Good.
These are tangents. I'll give you that those are tangents. If I tell you this angle right here is, I'm going to make it easy on us. Let's say that angle is 40 degrees. Every now and then I really want to be mean and I just can't do it. Let's say this circle has a diameter of 4 inches. And this circle here has a diameter of 10 inches. What I want to find is this angle right here. Tell me, where do I find right angles in this picture? Radius to a tangent. So in this circle, where would it be? There'd be one there and there'd be one here, wouldn't there? This is a right angle, this is a right angle. In this circle, it'd be there and there, right? So far I have 4 right angles, but I have no right triangles. Where am I going to get right triangles here? Split that down the middle. What's that make this angle? 20 degrees. Where else? Split that one down the middle. Don't know any angles there though yet. Now do I know any sides? Well, I know this side here is how much? How much? 2. There we go. This side here is how much? 5. So far, don't feel much closer to finding the angle. Let's look at this triangle here. The reason I'm looking at that one is because it's next to this one, and we want to know if we knew this angle here, we could double it and we'd have that whole angle, right? So we want to try to get to this triangle over here somehow. So I'm going to redraw that triangle. Let me do the right orientation at least. This is 20 degrees. This is 2 inches. If I am looking for this side right here, I'm going to call that side A. How do I find it? Well, I got my 20-degree angle. Which side do I know? The 2 is the opposite side. Which side am I looking for? Adjacent. Opposite and adjacent is what trig function? So tangent of theta equals opposite over adjacent. Do I know theta? Yes, I do. 20 degrees. Do I know the opposite side? So 2 inches. Do I know my adjacent side? No, that's side A. Better not know the adjacent side, otherwise I know everything and there's no use for the formula, right? So we cross multiply. 1 times 2 divided by the tangent of 20. We get 5.495 for A. Now remember, that is this distance right here. .495 inches. Does that make sense so far? Now I'm going to look at this triangle over here. I'm going to pull that out and work on it. I know that this side is 5.495 inches. I know this side is 5 inches. I'm looking for the angle, but not the side. Pythagorean theorem would give us that other side. So it's good thinking. Whenever you know 2 sides, you can find the third one by Pythagorean theorem if it's a right triangle. But we want the angle. I'm going to call that angle big B. So we're looking for angle big B. What side do we know? This is the opposite, and this is the adjacent. We actually know 2 sides. If we're looking for an angle, we have to know 2 sides. That would be the tangent again. Let's fill in tangent. We don't know the angle this time, so it's tangent of B equals, opposite is 5 over adjacent of 5.495. Now, since it is we're looking for the angle, we don't have to put in the over 1 and cross multiply and divide, do we? What do we have to do? Do the inverse trig function. We will have to divide the 5 by 5.495, but we can do that inside the trig function. So the tangent and inverse tangent cancel out. B is the inverse tangent of 5 divided by 5.495. So second tangent, 5 divided by 5.495, close my parentheses, equals 42.2996 degrees. Is that what my answer is? That's this right here. I want this right here, so I have to double it, multiply by 2. So 45.60 or 84.60 degrees. Is my answer. See how slick that works? You got it. Just a lot of steps. Yeah. A lot, so what? It's crazy? Oh, come on now.
It's not bad.
Yeah, look at all that math. It's just madness.
Let's say you have been hired to build a deck on a pool. It is a big pool, 36-foot diameter. The deck is supposed to start at a tangent here, come up to a right angle there, come down to a tangent here. They want this angle here to be 120 degrees. And they want this side out here to be 12 feet. Well, we're going to have some right angles. Let's draw them in. From the center of our circle, we got a right angle there. Got a right angle there. Guess what? We know that angle. How do we know that angle? This is 1, 2, 3, 4, 5 sides, right? If it's 5 sides, that means n equals 5. So the angle sum is 180 times n minus 2. Which would be 180 times 5 minus 2. 5 minus 2 is 3. 180 minus 3 is 540 degrees. So we've got 1, 2, 3 90-degree angles. We're going to subtract 90 3 times. And then we've got a 120-degree angle. So we're going to subtract 120 degrees. Which leaves us with 150 degrees here. 150. Now what? I haven't really told you what I'm asking for yet, have I? I want to know this length from there out. Gonna have to do some triangles somewhere. Well, the radius here is 18 feet, right? If I cut it from here to here, is that going to form a rectangle? A rectangle. No. Nice.
The other side has a rectangle.
Let's do this. Let's draw it out a little bit bigger here. A little bit better to scale. Up above us? No, there's no room. There's stairs next to us and it's dirt that way. That's a storage room for the conference center up above us that are moving tables and chairs in and out of the conference center. We can cut this down here This is a 12 feet here. This is 12 feet here. This angle was 120. This will be 90. This will be 30. We can do that. That tells us this is going to be 18 feet. This is going to be 6 feet, right? Now what?
Well, not in half, but we can make a triangle on the right side, because there's a right triangle.
You can cut it here. Okay, what do we know about that one?
Although it doesn't mean that it's split. No, because it doesn't split the 30 evenly.
It won't split the 30 evenly. You're correct. If the 18 and the 6 were the same, it would split the 30 evenly. But at this point, alas, it does not. What do you do? We know this angle down here has to be what? 150. We know that much. Now this is a right angle. What we would have to do here is cut it this way.
I was just thinking that.
I was thinking about like where
But you're thinking to yourself, there are no more right angles there now.
Oh no. Oh no. He did this on purpose.
It's called oblique triangles. Oblique triangles have no right angles. You guys should feel at home with these because these triangles just aren't right.
Thanks.
There are two options that we are going to look at. Law of sines. Second one, law of cosines. No, there is no law of tangents.
Good enough to remember.
For right now, I am going to settle for telling you that even though there are no right triangles here, we can solve this. We're not going to solve it today. We might not even solve it tomorrow. But by the end of next week, you will be able to solve that without right triangles in it.
Is that just using only degrees? Or what?
Using the angles, yes. There's relationships between the sides even if there aren't right triangles.
Sure.
Because remember, the sine is not a part of it. It's been related to the right triangle, but really a sine comes from a circle. Okay, I'm going to give you some stuff out of the book to work on. Page 743, exercise 35-1. That's like 3 through 13, the odd. And page 749, exercise 35-2. That's like 1 through 17, the odd. Solving the right triangles is not difficult. The difficult in some of these problems, especially the second set down here, is going to be finding the right triangles. And like we had to do with this one up here, there may be some where you have to find one right triangle, use that to find a dimension that you use on the next right triangle that solves the problem. Okay? So that's the tough part of these problems. And I'm telling you right now, these problems are tough, so don't get frustrated. Find a right triangle. See what it tells you. If it tells you nothing, find a different right triangle. Sometimes you'll find a right triangle, but you don't have any pieces that you can learn anything about them. So it's just a matter of find the right triangles, see if you have enough sides to find all the other parts of that right triangle, find other right triangles, see if you have enough parts to find all the other sides, until eventually you get to the point where here's a right triangle that has what you want, and you have enough pieces to find the missing sides of it. So these can be, they said, the more of them you do, the better you get at picking out which right triangles you want. But at first, you just have to start picking them out. I can show you which right triangles to use, but then at some point you're going to encounter a problem that's different than the ones I've showed you. So you're going to have to learn how to pick them out and trial and error at some point. No time like the present. So don't forget to work on that quiz and bring that back in tomorrow as well. I'll give you guys the last 10 minutes to get started on these.